This is Jacob from RoboFlow. Today I'm going to be showing you how to train a custom EfficientDet model in TensorFlow 2. So now, for a little motivation of the tutorial that we're going to be going through, I'm going to show you here the final image of what we're going to be working for towards today. This is a test image of cells in the bloodstream that our model has never seen. And you can see here that it's doing a pretty good job of identifying various cells in the bloodstream. Here we have white blood cells, here we have red blood cells, and here we have platelets. And the model is able to differentiate between these different objects, and it's able to tell which one is which, even having never seen this test image before. Today we're going to be particularly working on cells, but this tutorial is supposed to be general, so you are able to detect any custom object in the world that you decide, given the right data set and giving the right training set to be able to teach the model to identify the objects that you want it to identify. So for this tutorial, we're going to be using a platform called RoboFlow for our data management, pre-processing, organization, and export. And then we're going to be, for the deep learning technology, we're going to be using the TensorFlow 2 object detection API. And this is a really exciting new API that has been released for object detection, and it contains a whole host of models. And before we dive in, I'm going to give a quick little overview of the TensorFlow 2 object detection API. So here's a little blog post written by myself here, introducing the TensorFlow 2 object detection library. Here you can see they've presented this image of using TensorFlow for object detection. Again, this is sort of an example like we were looking at with the cells, in which the model is identifying different objects in a scene. Here it's a person and a kite. But as I mentioned earlier, this technology is supposed to be applicable to any sort of domain that you want to be applying it to. So here, if we look a little bit historically, there was the original TensorFlow 2 object detection API. This has notoriously stayed in TensorFlow 1 for a very long time, and finally they've gotten it up to speed and switched it over to TensorFlow 2. As you can see here is really the power of the TensorFlow object detection libraries. You can see here there's a whole list and a whole host of models that you can use. So in the original TensorFlow object detection library, they had some of the old models. They have models like faster RCNN, they have mask RCNN, they have SSD MobileNet v1, SSD MobileNet v2. These are all models that you can leverage with these libraries, and in this tutorial we'll see just how easy it is to be swapping in and out and changing up the different model architectures that you're going to want to deploy to be trying different experiments and seeing what is working best on your own custom data. So that's sort of the gist of the TensorFlow object detection API. So what's new in the TensorFlow 2 object detection API? I think the biggest thing here, the thing that we're most excited for at RoboFlow, is the inclusion of EfficientDet models. So EfficientDet is a state-of-the-art object detector, and it basically, the paper's design was to make a model that can efficiently scale as you're adding parameters. So there's a lot of ways that you can change an object detector to make it bigger. So you can increase the image resolution, you can increase the number of depths that your convolutional neural network has, you can increase the number of layers that is in the neck of your object detector as you're combining those the feature aggregations of all those convolutional network layers. And EfficientDet basically does all that for you. So as you move up the model size, it's efficiently scaling all these parameters in the way that the Google Brain team found was most effective. So really big thing here, EfficientDet is included, and we can see that in the TensorFlow 2 object detection model zoo. So here's another list of everything they have here. So they also have some key point detection. You can see that here with the CenterNet hourglass, and then here we have the family of EfficientDet models. that's the biggest thing that I think is going to be really the reason why you want to use this library, and a big thing that we're going to walk through today in the tutorial. You can see here there are other models like faster RCNN. There's SSD ResNet. There's SSD MobileNet V2, FPN Lite. So they're kind of taking these models and they're making them better over new iterations. And these are all implemented in TensorFlow 2. So some other features that come along with this library is the eager execution of TensorFlow operations. This means that graph operations are implemented in line as the code progresses, rather than before in TensorFlow 1 where you would set up essentially an inference graph and then you'd have to start a session and then you'd be coding in there, and it was kind of a huge mess. So very nice to have eager execution in this library. And then another thing that they boast with the new library is that you can use a variety of host of training distribution strategies. So you can train across multiple GPUs or TPU resources. Especially TPU, Google is going to really want to point you towards those if you need to scale up your training jobs. So let's go ahead and get started. So as we were looking at before, we are going to be working towards creating an object detector with TensorFlow 2 to be able to detect on test images that the model has never seen. So here's an example of what we're after. We want to be able to count blood cells in the bloodstream as our microscope, say, is scanning through a batch sample of blood. So in order to do so, I've collected here a data set of blood cell detection. So here you can see my data is in this folder. It might be in any format. Particularly here, we have it in Cocoa JSON. You might have it in Pascal VOC. You might have it in YOLO Darknet. You might have it coming out of Amazon SageMaker. Whatever format you have your data in, you can load it into RoboFlow and you will be able to process from there. So taking a little bit of a closer look, here we have the blood cell detection data set, and we have the validation split out. Here's the annotations, and here's a bunch of the blood images. And we have this in a few different test splits. But thankfully, RoboFlow is smart enough to be able to parse all these files for us. So we'll go in here. We'll first go to roboflow.ai. If you're new, you'll have to try it now and create a new account. Accounts are free to use for your first 1,000 images, so you should be able to go through this tutorial fine and be able to use some of your data sets to be able to train custom detectors. So assuming you have an account, as I do, you'll sign in here and just hit create dataset. Once you've hit create dataset, we can give our dataset a name. Let's call it cells with annotation group cells. And we're going to call this an object detection task. Notably, you also have classification and some other ones there. So here we go. We create our dataset. Now we are here at the dataset loading page, and in order to load our data in, we're just going to drag the folder over and load it in. So here we go. These are all our blood cells as they're being loaded into RoboFlow. And this is a useful point to kind of stop and check and make sure that everything makes sense. It looks like the bounding boxes are matching correctly. Here we can see that RoboFlow notices some things and is sort of cleaning your data set as it's loading in. Let's go ahead and continue on. Then after your data set is here in this sort of staging phase, you want to hit start uploading. Now we're able to split our data set into train, validation, and test splits. So a little bit more on that. You may want to split your data into training, validation, and test. So the training set is going to be the set that our model is going to be allowed to see, as it's actually optimizing the way that it's going to be mapping input data to export into inference predictions. And then we want to keep the validation set alongside the training set. So as we're training, we can kind of see how our model is training on the training set by taking a look at the validation set. And then at the very end, we'll use the testing set to make sure that the model is performing well. Okay, so now you can see here that our data has loaded in. It looks pretty much like the blood cell detection data set that I was expecting to find. So now you're in the RoboFlow dataset versioning step. So this is where you can be experimenting with different pre-processing steps. Here we have grayscale, just contrast, tiling. You can even modify your classes here too, and augmentation steps. This is where you can kind of augment your data and change the distribution of data and multiply your data to make a vastly larger data set of new use cases that weren't even included in your training set. And you can be creating data set versions here and iterating on research and trying out new things to see what is working best. For right now, we're going to keep it simple, and we're just going to resize to 416 by 416, and we're going to auto orient. Some other useful features here. You can see we have the dataset health check. This is where you can see sort of the distribution of your annotations, and as well as what your class balance is here. So here we can see that in this data set we have an overwhelming majority of red blood cells, and we don't have so many white blood cells and platelets. Generally, that's not a great idea to have imbalanced classes, but I will show you here in this tutorial that we will be able to train our detector with the data set as it is. But in general, this is something to look out for, because if a certain class is not appearing much in the training set, the detector will just learn to generalize over it, and will not end up detecting those objects, and that can be a problem for you later. Okay, so going back to our data set, we've chosen a few simple options here. We are auto-orienting and resizing to 416 by 416. Then you go ahead and click generate. I'll just call this version 1. And so basically, as you're generating, this is sending a job to the back end of RoboFlow, and it's augmenting and creating all the images. Then for this particular tutorial, you're going to want to choose TensorFlow TFRecord as your export format. That's very important. TensorFlow TFRecord is going to be the export format that TF2 object detection library models consume. And we've written the notebooks in such a way that you can slot in the TF records to be training on your own custom data set. So here you have two options. You can either download the zip if you're trying to run this tutorial locally. Otherwise, if you're in Colab, as we are going to be, you're going to want to use the show download code. So now when I click show download code, here, we will zip the files up. It will post to a web address that we can download. So here you can see we have a curl link. You want to copy that curl link, and we'll be bringing that over to the notebook come training. So that's where your data will download. So now moving over to the notebook. All right. So we have our data. It's been exported from RoboFlow, and we have a curl link now that we're able to download it. And I've gone ahead and downloaded my data already here in this cell, down here. But you can see that it's been blocked out because you'll also have your private key here, so you need to be careful who you share this link with. But here's my data. It's downloaded into the notebook from the content folder, and then train, and then you can see here's the TF records, and there are the associated label maps for each of the TF records. So here we go. Our data is in, and now we are ready to start on the training process. So in order to get started in this notebook, we'll start with the first section, which is to install the TensorFlow 2 object detection dependencies. So I'll go ahead and kick off the first cell. Right here we are pip installing the TensorFlow GPU package, which is 2.2. I've hard-coded this in here so we can all be sure that we're on the same TensorFlow package, so that's kind of a variable that is set. So this is one other thing you're going to want to check as you're in Colab is Colab gives you free GPU compute time, but you need to make sure that you use it. So here you can go in, change runtime type, and choose GPU. If you have copied this notebook from the Colab link, either in the bottom of this video or from the blog post, this should automatically be populated, but otherwise you might want to double check and make sure that the GPU is selected. Other things of note is you can use no GPU or you can use a TPU. The TPU is definitely something of interest to explore with the TensorFlow 2 object detection library, since it's well tailored to that. Okay, so next up, we're going to clone the repository, and we are going to get that all set up. And in the next cell, we're going to actually install from the repository the TensorFlow 2 object detection library, and we're going to actually install it as a Python package. So when we make calls to it, we can call it as if it's a package in our pip environment. Okay, it looks like that went pretty well. Next up here, this is a sort of minor detail, but ends up being a lot of code, is in order to export the model, there was a bug in the keras file, so just cat that file. Cat prints out the file for you, and then we make a few edits to it, and we can move forward past that. This isn't something you need to worry about. I would just copy the code directly. That will help us later when we're exporting our model weights. Okay, now we make some imports. And we're going to go ahead here and kick off the model builder test. This is a good way for you to see kind of if your GPU is configured, if you've downloaded all the packages correctly, and now you're going to go ahead and run the test to make sure that when we get down to training later, everything's going to be running smoothly through the pipes. So here we go. We can see it's setting up. Looks like it's setting up EfficientDet in the tests here. EfficientDet is built on the backbone EfficientNet, which we see printing out here. And EfficientNet is a large convolutional neural network that is pre-trained on ImageNet for classification. So you can take your convolutional network, pre-train it on a big classification data set, and then you can get the model to already start kind of understanding which features it should be looking for. So when you start doing object detection, then you're not starting from square one because you already have convolutional layers that are kind of tuned into these features already. All right, looks like all of these tests passed, and we're good to move forward. So right here, we just define a few helper functions to load and plot detections, load images and plot detections. That will help us later when we're wanting to visualize our inference. So now this is the next part, which we have kind of already largely gone through by looking at how to upload and download data from RoboFlow. This is how we prepare our TensorFlow 2 object detection and training data. So here you go. This is showing us to select TFRecord, which we did. And here you're going to paste your link in here where it says your link here. Again, I already did that. And here we're going to point to those files that we just imported. So you can see here that they imported as cells.tfrecord, and here we go. We're calling out those variables and pointing those for later as we go on to write our our model training config. So this is kind of the heart of the notebook here, where we're going to be writing our custom TensorFlow 2 object detection training configuration. Here you can really see this is the power of the library. I have a dictionary here of just a few models you can use, EfficientDet D0 through D3, and each one of those models has a model name. It also has a base pipeline file, which is going to be the basic file that we build on top of to build our model configuration. And then it also has a pre-trained checkpoint. The pre-trained checkpoint is going to be the saved weights from when Google took the same model and they trained it over the COCO data set. They got all those model parameters, and then they saved it down for us. So again, we don't have to start over from scratch. We can take this pre-trained checkpoint and then fine-tune from there for our particular task. Whatever object you may be detecting, you can start from that pre-trained checkpoint. And then these items if you want to try using a different model that I haven't put here in the notebook, come from the TensorFlow 2 object detection model zoo. So here you can see there are the EfficientDets, and if we look at this link, we can see that it downloads the pre-trained weights. So that's how you can get weights for any of these other models. You can get them right from the model zoo. Okay, so now that we've chosen our model, we're going to choose the smallest little EfficientDet. And then here you define the number of steps you want to train for and the number of steps that you want to evaluate for afterwards. So the number of steps is going to be how long our training job actually runs for. It's going to be how many times does the model iterate through our images as it's training. And then we can see here that we define also batch size. The bigger the batch size, the faster your model is going to run, but at some point you're going to run a GPU memory. So 16, I think, is about the level I got for the P100s that you get in Colab, but you can experiment a little bit with that for yourself and see if you can make that a little bit higher, especially if you're using a larger GPU in another environment. You might want to bump that number up for batch size. So then we'll go ahead and execute this cell. And then going forward, here we are going to download our pre-trained checkpoint. And looks like that came in all right. Okay, EfficientDet D0, pre-trained on Coco, check. And then we're going to go here and we're going to get the base configuration file. So that is, okay, EfficientDet D0 on Coco. Trained on TPU 8 was where they were training it. Okay, great. Now we have that config file. And here we're going to get the number of classes. So that auto-generates for you. So that's a common bug in training object detectors is you have to change the number of classes. Well, that will automatically happen for you here. And then here we just open up that base configuration file, and then we're going to overwrite some things. So we're going to overwrite where our training data is. We're going to overwrite what the label map is. We're going to overwrite where we have downloaded our fine-tune checkpoint. And we're going to overwrite like the number of steps to train and the number of classes. So once we put all that stuff in, we should get a training configuration that is good to go. All right, great. And here, this is just a good sanity check. I would recommend reading through this as you go through to train your own detector. But you can see here we have number of classes, and you can see to make sure that we've edited the training configuration in the way that we want it to. So here we go. This is looks pretty good to me. So once you're satisfied with that, you can move on here. Make sure to execute that cell, and then we can move on to training. So here we're going to call a training script. That training script is going to reference the pipeline file, and it's also going to save to a specified location that we specified here with the model directory. And it's going to train for the number of steps and eval at the number of steps that we specified above. So okay, we're going to kick off training here, and this takes a little while to set up. It's kind of building the network and accessing the GPU and getting everything ready for training, caching the data. So while that's going, we're going to go ahead and move on in the notebook. Luckily, in this notebook, the cell's output is saved, so we're going to go ahead and move on and act as if training has kicked off, but we'll come back up here to revisit, and kind of see how things are moving as training is going to go through. But this will be a pretty long process. This library has benefits insofar as it contains a lot of models, and you can switch between abstractions easily, but these abstractions take a long time to train, and the code takes a long time to execute. So training time is going to take some time for you on your data set here. And of course, you have options to speed that up if you wanted to use a larger GPU, or to shard your data and start to use different TPU resources to be able to train across a distributed environment, so you can try to speed up your training. But after it's done, you'll go ahead and you'll see loss curves like this. So we want to see a loss curve like this that is downward sloping and then starting to flatten off. This basically shows that the model is starting to fit to the task, and it's starting to learn the way that it should be making predictions. And once the loss curve has started to level out, the marginal increase and continuing to train is starting to decrease, and the model is getting better and better. Okay, so moving forward, in this cell here, we can export a trained inference graph. So this shows code that you're able to actually export this model from a checkpoints. As it's going to save down here, you'll see it's exporting checkpoints. You can choose one of those checkpoints and you can export it, and you'll get a .pv file. So this is a more mobile file, and you might be able to move this more into downstream applications that you need to be using this object detector for. So that's how you get the .pv file. And now we'll go into the most interesting part of the notebook. Assuming that we've already trained a custom object detector, how do we actually use that for inference so we can start to go on to use this on test data that the model has never seen. So here again, you'll want to export your data and put your link here. This is just so we can get to the underlying images. TFRecords kind of bundle all the data formats into one place, so you can actually get to the underlying images. But here I just exported the same data set in Cocoa JSON. So you would be back in RoboFlow, and you'd be going to export, and you would choose Cocoa JSON. And so there you go, test images come in, and you can execute a few cells to set up our inference. You can see here, again, I've printed out the checkpoint, so you can choose the checkpoint that you want to do inference with, and this will rebuild the model and kind of re-access the model, get the model back up, and get the inference graph rebuilt and ready to run. And then again, we define some label maps so it knows what is what. And then in this code here, we're choosing a random test image from the test data set, and then running it through some code to make inference. And then a visualizer will visualize the image based on the detection boxes. And here you go. Now we have a custom detector that has been trained to detect our custom objects. And we can see here that it's doing a pretty good job. So thanks for following our tutorial today on how to train EfficientDet in TensorFlow 2. Stay tuned and subscribe below if you want to keep track of how to train all of the latest and greatest state-of-the-art models in computer vision. And also stay tuned for other interesting tidbits in computer vision and how to augment your data and how to get the best results through using RoboFlow. So thanks guys, and happy training.